This is Jacob's Algebra, Chapter 12, Lesson 7, Part 2. We're going to finish with problem number 7e. We had started the problem and solved for x and got that x equals 4. But once you've done that, you have to check your answer in the original equation to see if it works. So our original equation was 2 square root x plus 4 equals 0. So we're going to replace our x with 4. So we're going to have 2 square root 4 plus 4 equals 0. Well, what is square root 4? The square root of 4 is 2. So this is really 2 times 2 plus 4 equals 0. Well, 2 times 2 is 4, and when we add 4 to it, we get 8. Does 8 equal 0? No. That means that x equals 4 does not work, so we have to say this one is no solution. So there is no solution for this one because the solution that we get does not give us the correct answer in the end. Okay, let's do another one. Let's look at number 7f. Number 7f is 2 times the square root of x plus 4 is equal to 0. Is equal to 0. Okay, so what we want to do is isolate our radical. Right now we have 2 multiplied by our square root, so let's divide both sides by 2. So I'm going to write divided by 2 for both sides. Well, 2 square root x plus 4 divided by 2 is just square root of x plus 4. And 0 divided by 2 is just 0. Now we have a square here and we want to get this x out of it. The only way to do that is to square it. So we're going to square the left side, and when we do that, we have to square the right side. The square of the square root of x plus 4 is just x plus 4, because when you square a square root, your answer is whatever was inside of that square root. And then 0 squared is 0. So now we have x plus 4 equals 0. We need to isolate the x, have the x all by itself. Right now we're adding 4 to it. The way to undo adding 4 is to subtract 4. So we're going to subtract 4 from both sides, because whatever we do to the left side of the equal sign, we have to do on the right side. So x plus 4 minus 4, that's just x. 0 minus 4 is negative 4. Now, we've found a solution for x. Now we have to go back and check it in our original equation. Our original equation was 2 square root of x plus 4 equals 0. So I'm going to replace the x with negative 4. 2 times the square root of negative 4 plus 4 equals 0. Negative 4 plus 4 is 0, so this is 2 times the square root of 0 equals 0. Well, what is the square root of 0? The square root of 0 is still 0, and 2 times 0 is 0. So yes, this works, and x equals negative 4 actually is a solution. So x equals negative 4 is our answer for this one. Let's look at number 7g. 7g says the square root of 2x plus 4 is equal to 0. Now, the first thing we want to do is get our radical all by itself, because the radical contains our x. Right now we're adding 4 to our radical, so to get rid of it we need to subtract 4. So we're going to subtract 4 on both sides of the equal sign. So when we subtract 4 on the left side, we get just square root of 2x. When we subtract 4 on the right side, we get negative 4. Now we need to get the x out of the square root. The way to do that is to square it. When we square the left side of our equation, we have to square the right side of our equation. Be careful, because you have to square the entire thing, not just the number 4, but also the negative in front of it. So when we square a square root over here on the left, we get the number that's inside of the square root. The square of the square root of 2x is going to be 2x. The square of negative 4 is going to be 16. So now we have 2 multiplied by x. How do we undo multiplying by 2? We divide by 2, because dividing is the opposite of multiplying. So when we divide our left side by 2, that means we need to divide our right side by 2. 2x divided by 2 is x. 16 divided by 2 is 8. So we get x equals 8, but we're not done yet. Now we have to check it back in our original equation, which was square root of 2x plus 4 equals 0. So we start off with the square root of 2x. Our x is 8. So 2 times 8 is 16. So we have square root of 16. Then we have plus 4 and then equals 0. The square root of 16 is 4. And then we copy down our plus 4 equals 0. Does 4 plus 4 equal 0? No, that doesn't work. That means x equals 8 is not actually a solution. This one we would write no solution. Or you could write not possible. So 7G does not work. Let's take a look at another one. Try number 7G. I'm sorry, we did 7G, 7H. Okay, 7H is the square root of 2x plus 4. This time it's all under the square root, is equal to 0. So all we have on our left side is a square root, and that's the only square root we have. So we can go ahead and square both sides. When we square a square root, our answer is what's inside the square root. So this is going to be 2x plus 4 on the left side. And then 0 squared is just 0. Now that we have the x outside of the square root, the next thing we need to do is isolate our x term. So we need to get the x term by itself. So right now we're adding 4 to our x term. The way we undo that is to subtract 4. So we're going to subtract 4 from both sides. When we do that, we end up with 2x on the left and negative 4 on the right. Now we need to isolate our x. We're multiplying by 2. The way you undo multiplying is to divide. Since we're multiplying by 2, that means we need to divide by 2. And when we do that to the left side, we have to do it to the right side. So 2x over 2 is x. Negative 4 divided by 2 is negative 2. Now we don't really know if this is actually a solution until we check it in the original equation. The original equation, we had square root of 2x. Well, our x is negative 2. 2 times negative 2 is negative 4. And then we have plus 4, so plus 4 in the square root, and then it said equals 0. So what is negative 4 plus 4? That's 0. So we have the square root of 0 equals 0. That's true. That means that x equals negative 2 actually is a solution for this equation. Okay, let's try number 7, part I. That one says the square root of 2x minus 7 is equal to the square root of x plus 9. Now, anytime you have a problem that involves square roots, you want to get either a square root all by itself on its side, or you want, well, really that's what you want. You want to get square roots by themselves. So we have a square root on both sides. Since both sides are in a square root, that means that what's in the square roots has to be equal. That means that 2x minus 7 has to be equal to x plus 9. Now you could also get this by saying, well, we can square both sides, and squaring gets us what's inside the square root. But you can also think about it if a squared, well, if the square root of a equals the square root of b, then a has to equal b. So we have 2x minus 7 equals x plus 9. We want to get all of our x's on one side and all of our numbers on the other side. So what I'm going to do first is subtract x from both sides. When I do that, on the left side, I will end up with x minus 7. On the right side, I'll end up with just 9. Now, to get the x all by itself, I'm subtracting 7 right now, so I need to add 7 to get rid of that. So on the left side, I will end up with just x, and on the right side, I will end up with 16. Now, I don't know that this really works until I try it back in my original equation. So we have the square root, 2 times x, that's 2 times 16 is 32, and then it says minus 7, is equal to the square root of x is 16, and then plus 9, plus 9. So what is 32 minus 7? That is 25. What is 16 plus 9? That is 25. That works. We get square root of 25 equals square root of 25. It works. That means that x equals 16 actually is a solution to our equation. So we'll try another. Let's look at 7J. 7j says the square root of 2x plus 7 is equal to the square root of x minus 9. Again, if the square roots are equal, that means that our numbers what's inside of the square roots has to be equal. So we can say 2x plus 7 is equal to x minus 9. We want to get all the x terms on one side, so I'm going to subtract x from both sides. So on the left side, I have 2x minus x, that's just an x, and then I still have a plus 7. On the right side, I have x minus x, that's 0, and then we still have a minus 9. Now, right now, I am adding 7 to x. The way to undo that is to subtract 7 from both sides. So I end up with x equals negative 16. Now I need to try this in my original equations. So I have the square root of 2 times negative 16 is negative 32. And then we have plus 7 is equal to the square root of negative 16 minus 9. So on the left side, what I end up with is the square root of negative 25. On the right side, I end up with the square root of negative 25. Now, these things are actually equal, but in Algebra 1, we're not allowed to take square roots of negative numbers. That means that this is no solution, or you could write not possible. Let's do just a couple more, especially part 7L. What if you have something like the square root of 8x is equal to 3 square root 2? Okay, we have square roots on both sides. So what we want to do is get rid of these square roots. I can't just say that what's inside the square roots is equal, because on the right side I have a number multiplied by my square root. I don't just have a square root on the right side. So what I'm going to do is square both sides. So on the left side, the square of the square root of 8x is going to be 8x. On the right side, I'm going to have 3 squared times the square root of 2 squared. So we're going to have 8x is equal to 9 times 2. And 9 times 2 is 18. So we have 8x equals 18. So right now we are multiplying x by 8. To undo that, we need to divide by 8. Please don't just punch this in a calculator. This is a fraction and I want you to simplify it. When you look at the 18 and the 8, they're both even numbers. That means we can divide them both by 2. So x will equal 9/4. Now the next part says, next thing we need to do is to check this in our original equation. So we have the square root of 8 times 9/4 is equal to 3 square root 2. What is 8 times 9/4? Well, 8 divided by 4 is 2, and 2 times 9 is 18. So we have the square root of 18 is equal to 3 square root 2. Well, let's simplify this 18. 18 does have a square factor, 9. So we can write 18 as 9 square root 2. And when we take 9 outside of the square root, we get 3. And we still have a 2 left behind. That means that what we started with does equal 3 square root 2. It works. So x equals 9/4 is actually a solution to our equation. Okay, so now what we're going to do is move on and look at some of number 8. So number 8 says, although the following equations contain square roots, they can be solved without squaring because the variable is not under a radical sign. Remember, a radical is a square root or a cube root or a fourth root. It's some kind of root. So let's take a look at a couple of these. Part A, we have x minus the square root of 10 is equal to 10. Well, right now we're subtracting something from x, so to get rid of that, we need to add it to x. So we're going to add the square root of 10 on both sides. And what we'll end up with on the left side is x, on the right is 10 plus square root 10. Let's do another one, 8b. We have x over square root 10 is equal to 10. Right now we're dividing by square root 10. To undo that, we multiply both sides by square root 10. We will end up with x equals 10 square root 10. Let's do just one more, 8c. We have x plus square root 3 equals square root 27. So x plus square root 3 equals 27 is 9 times 3. We can pull a 3 out. That's 3 square root 3. Subtract a square root 3 from both sides, and we get x equals 2 square root